Hello, I'm Wong from Multimedia University. To begin with, my project, flood monitoring using remote sensing approach, address flood detection, which is a critical challenge as floods account for 44% of global natural disasters. Our deep learning system analyzes the satellite imagery to detect floods with high accuracy, specifically distinguishing between permanent waters and new flood areas. So here are the Cent1 Floods 11 dataset that I'm using. And here is the model architecture for both proposed model. In this case, the advanced neural network will classify the satellite imagery into three categories, namely the background, permanent water, and flood water. We will compare two architecture, which is the HRNet plus OCR and attention UNet, with the later one actually providing superior in both accuracy and speed. As you can see here for benchmarking comparisons, our attention UNet model actually achieved 81% of IOU intersections over union accuracy, far exceeding the traditional methods of 34 and 38%. It also processed image 1.8 times faster than the alternative, making it ideal for time-critical response. As for the visualizations, in this example, this one is the ground truth, and this one is actually the prediction made by our model. You can actually see that our model can accurately identify permanent water in blue and flood water in red, which is a critical distinctions that conventional systems absolutely cannot do. Subsequently, let me now demonstrate our complete flood alarm system in action. Let me run this code. The process will begin with satellite data acquisitions. Here we are using a testing set that is new to the model. The pre-processing pipeline will then calibrate and enhance the image, applying sparkle filtering and enhancing water filter. Oh, a buzzer sound. That means most probably we have flood occurring here. In this case, the threshold will be set to be 5%. This threshold is always customizable, but for this example, I will set it to 5%. In this case, as you can see here, the red pixels here actually represents the flood water, while the blue one will represent the permanent water. Let us look at another example. So here is the visualizations of the flood alert again. As you can see, we have blue pixels here, meaning this is most likely permanent water bodies and a lot of flood area. Let us look at another example. So this example, it only has a 0.64% of flood water, which means it doesn't exceed any threshold, meaning that the buzzer won't be alert. Let us look at another one. Set. It has a 0% of flood water, so the alarm won't be set off. Yeah, so this is how our flood alarm system actually works. That's it for the demonstration. Thank you. In conclusion, as for the commercial applications of this project, this technology will address a whopping 40.5 billion market for disaster management solutions, targeting mainly the government agencies, insurance companies, and humanitarian organizations. So by transforming the flood monitoring from reactive to proactive, our system provides critical time advantages for emergency responders, ultimately saving life and reducing economic impact. That's it from me. Thank you for watching.